Tangents and normals. Objectives. By the end of this lesson, you should be able to inform and explain what a tangent line is, find the equation of a tangent line at a point given f of x, explain what a normal line is, and find the equation of a normal line. Let's start with a tan line. Right, so we all should know what a kind of tan line is if you ever took geometry. Right, so here's your wannabe circle. A tan line hits the circle at one spot only. So it's like something to this effect. Right, so you only hit at one spot, you don't go inside. That's a tan line. So it's a tangent line. A secant line is kind of something that hits it at more than one spot. So if you ever see that's a secant line, we're not going to care about that so much in this class, but a tan line hits it at one spot. The same thing applies for curves. I give you a curve right here and I want a tangent line at a spot over here. So I just want to be able to hit it at one spot, kind of like that. As we learned in the past couple of lessons is that the slope of that line, right, not the line itself, but the slope of that line is a derivative at that spot. Or I could do something over here, yada, yada, yada. Right? So that's what this picture shows. You have a little line there, and that green one there is a tangent line, right? The slope of that line is a derivative. So what we're gonna do here is I want to find, instead of just finding the slope of that line, I want to find the equation of that line. So how do we find an equation of any line? Same way we did in algebra 1. We use our point slope equation. Right? Point slope, which means all you need is a point, which we happen to have, and a slope. Now, slope is a special one, right? We're talking about slope of that line right there. And remember what that slope of that line is? The derivative. So slope is just mean the derivative at the point and the point at the x value of the point. That's kind of the idea. If I want a slope of a tan line, all I'm going to do is a normal point slope form equation where x1, y1 are the points they give you. Right? If you have the x, you plug it into the original function, get the y. And the only thing that's kind of special is the slope here. That's the derivative at x1. Once you plug it in there, that's your equation of a tan line. Right? You always find an equation of a line the same way. If you want an equation of a linear line, it's always done this way. Right? So a couple things to keep in mind, right? M is a slope, so that's formula right there. This is how you could write it if you just want to use it in that form, but I just kind of do this. But it's there if you need it. So let's do an example. Right, so here's the picture. We're going to find the equation of x squared. I want the equation of a tan line at x equals 5. So I want that pink line right there. Right, so the first thing I do is, I want an equation of a line? Easy. Y minus y1 equals m x minus x1. Right, that's how you always find the equation of a linear line. And you have your x1 right here. There's x1, so that's your 5. And just like in algebra 1, if you have your x and you want to find the y that goes with it, you plug it into the formula. So if I want y1, just plug that value in. It's going to be f of 5, which is 5 squared, which is 25. So that's my x and my y1. Right, the only thing that's different is the slope here. Since we're doing the slope of a tan line, right, this is an equation of a tan line, which means that's the slope of the tan line. That's a derivative. Right, so this is a derivative at x1. So let's take a derivative of this. F prime of x, bring it down, subtract 1 off, 2x. Now again, I see a lot of people just plug this in. I'm like, what are you doing? This is the derivative. I want the derivative at a point, so don't ever just plug that into the m. Right, I want the derivative at a point, and that point being the x1. So you don't just plug 2x in there, you have to plug a value in. So f prime of 5, which is 2 times 5, which is 10. So there's my equation. Y minus 25 equals 10x minus 5. And that is a fine equation. It's in point slope form. That's all good. Right? You don't have to do anything else. Unless they specify. And now if they specify they want a slope intercept form, kind of like you have it right here, then you got to solve for y, right? So again, that's fine unless they specify. Hopefully you don't cross over the numbers like I did. But if they want it in slope intercept form, then you just do that. Distribute y minus 25 equals 10x minus 50. Add 25 to both sides. Y equals 10x minus 25. right? Again, so you don't need to do this unless they ask. If they say put in a certain form, then you have to do this. Otherwise, this is totally fine, right? Either way, it's the same answer. So that's our first example. Let's do another one. Find the equation of tan line to f of x equals x squared plus 1 at the point x equals 1. Right, so again, I want the equation of a line. You just go y minus y1 equals m x minus x1. You have your x1 already. If you want to find the y1, just plug it in. Just plug that into the original function, and I get 2. And now if you want the m, you just gotta remember that's a derivative. It's the slope of a tan line, so it's a derivative at x1. At x1 is being very important, right? You gotta plug it in, you don't just plug an equation in. So my derivative here, f prime of x equals 2x. Plug in your x1. So just 2. And then I'm done. Y minus 2 equals 2, x minus 1. Again, unless they specify, that's all you have to do. Let's see this next example. That's the same one. So we're just going to skip past that and pretend I didn't do that. So here, suppose f1 of 4, suppose f of 1 equals 4 and dy dx equals 1 minus x squared. Find the equation of tan line to f of 1 at x equals 1. So a couple things going on here. What this is it's the same idea. Find the equation of a tan line. So I'm going to go y minus y1 equals m times x minus x1. I still have my x1 right here. 1. Now remember the way you find y when you plug it in? They don't give me any equation. Like, that's a derivative. I'm not going to plug it in there. But look what they tell you right here. Look, they do the work for you. They're like, hey, when you plug in 1, it equals 4. That's my y1. Right? So all I got to find my slope. Now remember what slope is? It's the derivative at x1. So it's not just, that's a derivative right there, right? That's the notation for derivative, but it's not just that, you don't just plug that in. It's at x1, so you gotta plug 1 in. So I plug in 1, I get 1 minus 1 squared, which is 1 minus 1, which is 0. So at 0, I get y minus 4 equals 0x minus 1. That is fine to leave it like that. People are gonna think you're weird though, because you don't know what 0 times anything is 0. So you get y minus 4 equals 0, or y equals 4. Which is a fine answer. Right? Don't be scared by the zeros. Let's do one more of this type, and then we'll move on to the second type of problem. Find the equation of the tan line. Find the equation of the tangent to y equals sine of x at the origin. Right? So it's a little different. They don't actually give you a point. They just tell you it's the origin. That tells you all you need to know, though. Origin 0, 0. So if I want to make equation of my tan line, ignore the line. Y minus y1 equals m x minus x1. 0 goes there, 0 goes there. Right, it's my x1 and y1. Remember how you find a slope? You take the derivative. So I can take my derivative of sine. So y prime. Derivative of sine is cosine x. Now remember, you're not done. That's a derivative. You don't just plug the derivative in. You want the derivative at x1. So I got to plug in my x1, which is 0. Cosine of 0. You guys should all know what that is by now. 0 is right here. 1, 0. Sine e, cosine x. So this is just going to be 1. I get y minus 0 equals 1, x minus 0. Also known, if you simplify that, as y equals 1. So that's it for tangent line, right? Very straightforward. If you want to find the equation of a tan line, just write down the equation of a line like you've been doing since grade school. And then your x1 goes here. If you don't have the y1, you plug it in. If they give it to you, even better, just plug it in. Only thing that's kind of funky is the slope. So we're doing the slope of a tangent line, which means that is literally the derivative. So take a derivative and plug your x1 in. There you go. So let's move on to the next type of line. That's a normal line. So here's the gist. Normal line is a fancy term for perpendicular. That's it. Right? So if you have a tangent here, the normal line is perpendicular to that tangent line. So remember what that means? If you guys remember perpendicular lines, it's the negative reciprocal of the tangent line, right? So you flip it, change the sign. If the slope for the tangent line equals 3. My normal line slope would equal, flip it and change the sign, negative 1/3. That's all it is. Everything else is exactly the same. Only thing that changes is that. So if I go up here, right, and let's go a little further. So like, let's go to this one, right? That was the equation of my tan line. Hey, tan line. If I want to make this a normal line, all I do is change that thing right there. So it's gonna be y minus 2, do the negative reciprocal, 1 negative 1/2, x minus 1. Now boom, it's a normal line. That simple. So let's do a problem or two just like that. So here, right, find the equation of normal tangent line and the normal line to the curve. So, right, I want the equation of a line, y minus y1 equals m x minus x1. Plug your x1 in. Plug it into, remember if you want to find y1, you just plug it in. So 3, 1 squared plus 1, 3 plus 1 is 4. Remember this goes first, so you get 4. Right, I want to find my m, so you just take a derivative. That's all the m is. It's the slope of a tan line, so derivative. So that would be 6x. That's my derivative. Now again, you don't just plug that in, you got to plug it in. It's a derivative at x1. My x1 being 1 in this case. So this is 6 times 1, which is just 6. So my slope is 6. Right, I took the derivative, plugged 1 in, I'm good. That is my normal line. Right, it's the equation of my normal line. You want the equation of the sorry, not my normal line, it's my tangent line. Oh, tangent line. Don't tell anybody, I messed that up. So my normal line, all you do is change that thing, and you get y minus 4 equals negative 1/6 x minus 1. All done. Let's quickly look at this one. Find the equation of the tan line normal to this. So what's the difference here? Not much, just that they gave you a point here. Don't freak out. That's your x1 and your y1. They did most of the work for you already. You go y minus y1 equals m x minus x1. This is 1, that is 4. That part's done. All I need to do is take a derivative of this. That looks kind of sucky though. Right, so remember the way we do that, we have to rewrite it. X to 1/2, flip it up for x to negative 1/2. Now again, I just did algebra. Haven't took any derivative yet. Let's take a derivative. So bring that down, subtract 1 off, and I get negative 2x to the negative 3/2. Also known as negative 2 over x to the 3/2. Why did I do that? Only because I'm going to plug in 1. Actually, I didn't need it because it's 1's easy. Whatever, sorry. Right, so now let's plug in 1 and find the slope. So if I plug in 1, my slope's going to be negative 2 over 1 to 3/2. Doesn't matter, it's just negative 2. Now again, that would be my normal line. I'm sorry, I keep on doing that. That would be my tangent line. Right, I haven't flipped it yet. So if I want to find the equation of my tangent line, just plug it in. But I want the normal, so we're going to flip it and change the sign. So 1/2. Right? And that's how we do it. You have a point, that's your x1, your y1, because they actually gave me the point. If I want the equation of a tan line, right, like m is literally the derivative, so you take the derivative and plug your x1 in. I got negative 2. In this case, I wanted the normal line, so I had to flip it. So that's just the idea, but let's do a few more just to broaden our understanding. So look at here. So the equation of a tangent line to y equals natural log x at the point where y equals negative 1 is this. Right, so this is a classic IB show that problem. They give you the answer. They just want you to show you how you do it. So remember, you cannot use this. They're just letting you know, hey, that's the answer. Why would they do this? A lot of times it's a part A of like a 3-part problem. They want you to make sure you have this for the next parts of the problem. Right, so that's what they do. That they want to make sure you have this so you can use it for the rest. But let's just do this. So find the equation of a tan line. So we know how to start. Y minus y1 equals m x minus x1. Right? Now they gave me the point here, y equals negative 1. I don't have my y value yet, so I got to plug that into the equation. So y equals natural log of negative 1 Oh, whoa. Sorry, I almost messed that up. Let's go back. Let's do this all live. I read that wrong. They gave me the y, not the x. Right? That's the y value. That's -1. So when I plug it into here, it's -1 equals natural log x. Oof. That was embarrassing. Right? So I have to find the x actually. I have to find the x1. So we have to solve this. That's not too bad. We know how to solve how to get rid of natural log. You just do the e to both sides. E power to both sides. These cancel out. You get e to the -1 equals x. Or if you want, x equals 1 over e. Like that. Now remember, m is just a tangent line, so I just got to take a derivative, right? The derivative of that. The derivative of that, y equals natural log of x. The derivative of that would be, well, it's natural log 1 over x times the derivative of the inside, which is 1. So just that. Now, as always, right, that's just now my m. I got to plug my x1 in. So plug that in. 1 over e. The way that works, that's 1 divided by 1 over e, also known as 1 times the reciprocal. Right? So it's complex fraction, 1 over this, just rewrite it. 1 divided by that. So then you flip this side. So I just get e. That's my slope. So if I simplify this a little bit, 1 plus y plus 1 equals e x minus 1 over e. Now again, the whole point of this was like I had to get it to look like that. That's what a show that does, right? I gotta make it look like this. It does not look like this right now. I gotta get y by itself. So let's just do some algebra. Distributes y plus 1 equals ex. Now, e times 1 over e just cancels out. Subtract 1 from both sides. And y equals ex minus 2. And like magic, or mathemagic, they match. Let's do one last example to make sure we got this. So look at this one. Find the coordinates of the points where the tangent y equals x, so the tangent to y equals x cubed plus x plus 2 at 1, 4 meets the curve again. Right? So we have some thing like this. And what it's saying is, if you find let's say we find our tangent line to like the point right here. If you draw a tangent line, so where the graph's gonna work, you're gonna hit it again. So we want to find out what that point is. So you know what we're gonna do? Well, we're gonna find the equation of that tangent line. Let's just say, I'm just gonna make this up. Let's say that it's y equals 3x plus 4. Right? And how do you figure out where it hits the curve? Well, you set it equal to y equals our original curve. How do we solve that? We just use our calculator. And we'll graph it and find the answer. So, but for now, let's find the equation of a tangent line, right? So in this case, I want to find the equation of a tangent line. So y minus y1 equals m x minus x1. Algebra 1 so easy, so much fun, right? We have our, look at that, easy. Give us the x and the y already. Are you kidding me with this? Right, so we have our x1 and our y1. All we gotta do is find the m. Remember the way we do that? We take the derivative and plug our x1 in, right? Because that's the slope of a tangent line, which literally means the derivative. So 3x squared plus 1. Plug our 1 in, right? Don't ever plug that in there. Plug the 1 in. So 3 squared plus 1. Do this first. And you get 3 plus 1, which is 4. So this I'm actually going to simplify since I want to actually solve this problem. I'm actually going to simplify so I can put in my calculator. So I'm going to distribute a little bit. Y minus 4 equals 4x minus 4. Add 4 to both sides. And I get y equals 4x. So I have y equals 4x. I have y equals x cubed plus x plus 2. Now I want to find out where these things cross. So the easiest way to do it is in your calculator. I won't bore you with the details. We'll probably do it in a class later. But all you're going to do is graph both of them. And they're going to cross at 2 points. So something to this effect. You just that's probably the one we found originally. You just got to find the other one by using the intersection. And that's the idea. One last thing before I go. Some special cases. If your tangent line is like an x squared, like a basic, or in this case negative x squared, well then your tangent line is going to be like something like y equals 0. We did a couple of those way up there. Right, our last few ones were like that. You had y equals 3, y equals 1, y equals 3. In that case, right, notice how your y is equal to 0? Well, your normal line, negative reciprocal of that, you can't do it. It's going to be a vertical line. So how does that work? Well, let's say your point was, you plug your point in, you get like 0, 2. Well, y equals 2 is a tangent line. The normal line is going to be x equals 0, right? It's the x value, because that's x equals that. Same thing the opposite way, right? If it looks like that, that works. And remember, also if it's an x cubed graph, right? Let's say you found your tangent line was y equals 0. Well, plug it into the equation to figure out what the x value is, and let's say you get like 3, 0. Well, the normal line is just that thing, the x value, x equals 3. And it can work the other way also. Let's say your tangent line, let's say when you did that, it didn't work out, you just got x equals 1, right, like this. Well, how do you find out what the normal line is? Because you can't do the negative reciprocal, the slope's undefined. Well, the same idea. If you have your x value, plug it into the equation to get your y value, and let's say y value is like 3. Well, the normal is going to be the y value. That's the idea. So this special cases, right? When you get your tangent line, it's like just it's only one variable. That means your normal line is also going to be one variable. It's just the other variable. So if your tangent line is x equals 1, your normal line is going to be y equals something. Sitting up here, right? If your tangent line is y equals something, your normal line is going to be x equals something. And that's it.